Welcome to the Nonprofit Report, your update on nonprofit organizations, issues, and leaders. I'm your host, Mark Oppenheim, and today we're discussing how science can save oceans with Dr. Jim Sullivan. It's all on you, Jim. You have to save the ocean. You have 2 hours and 15 minutes. Executive Director of the Harbor Branch Oceanographic Institute at Florida Atlantic University. And I'm so excited to be here, Jim, to talk with you about this really, really important topic. So thank you for coming to us from hurricane-ridden Florida.
Well, thanks for having me. It's a topic I really enjoy. Well, I don't enjoy talking about it in some ways, but it's a topic that's really important that people understand.
So when I was coming up, we used to see these sci-fi movies where scientists were the voice of reason. They were the ones who saw things first. The film would always go to people listening in rapt attention as scientists were describing problems and rational solutions and so on. And now we're at the point where disinformation is king and truth and obfuscation are given equal weight. Could you talk with us in that 1950s sci-fi way as the voice of scientific reason, and we can all sit at the edge of our seats and hang on your every word? Could you really describe, and in all seriousness, describe the situation with the oceans, because they're not an infinite resource anymore. Human impact is felt from the Antarctic to the Arctic. Talk a little bit about your take on the state of the oceans today.
The oceans at this point, everyone's familiar with global warming. I think we can all agree it's actually occurring now. And of course, with global warming, which is a byproduct of CO2 pollution, we have climate change, which we're witnessing, unfortunately, across the world. But we also have ocean acidification, which is dropping the pH and making, as it sounds like, the oceans more acidic. And you might not think, well, how is that bad? But it really affects a lot of marine life. A lot of animals that need to form shells and other structures like coral, they can't do it in an acidic ocean. So you can see entire food chains collapse over just acidification. It changes the chemistry of the oceans. But global warming is just one thing that we're doing. And this is a huge issue, but the oceans have been having really significant damaging effects from mankind since mankind's been around. And beyond just the big picture of global warming, we are now seeing, coral reefs dying out. We're seeing biodiversity loss in our oceans, which is a huge issue. Overfishing, we've pretty much exploited our oceans for all the food we can pull out of them. Fishing has basically peaked now. We can't take much more out of the oceans. Other forms of pollution besides CO2 that we put in the atmosphere, plastics are a major issue in the ocean now. Microplastics, people have probably heard of the Great Pacific Garbage Patch, mostly plastics. And nutrient pollution. We all like to live by the coast. Coastlines are very beautiful, but we get a lot of pollution from farming, from septic systems, from industrial use, you name it, it happens. And that causes things like harmful algal blooms on our coasts, which are huge issues. It's just the oceans can't take continued punishment. At some point, we're going to hit tipping points on a lot of issues. And we have to take control of this and start trying to restore our oceans and not just keep on pounding them. They'll recover if we give them a chance to recover. But we're hitting them with a lot of different problems simultaneously.
Now, theoretically, we should be smart enough to actually see this coming. I mean, we're seeing hurricanes of a power on a regular basis that we had never seen before. So you see the actual impact of global warming. You see the melting of the ice caps, which is not something we had seen, and it's happening at a very accelerated rate. The microplastic situation, all you have to do is look at a glass of water and you think, well, there's a portion of this that I'm drinking here is plastics. So I'm going to be ingesting these plastics. We've seen.
We're finding them we're finding microplastics in humans now. I mean, this
Right.
is, you know.
And you're seeing, right, where rivers die and then they wash into the ocean. Well, that death is washing into the ocean, and the death is caused by pollution and forever pollutants. How do we shift this? Because we can't turn it off like a light switch, right? What kinds of actions can we take in our everyday lives that attach to the science that actually allows me to make a contribution to solving this problem? In other words, when I get up off of this chair and I exit where I am, what are the behaviors when I go into a restaurant, when I go and I make a purchase, when I go and get into a car? What are the behaviors that actually allow us to solve this in a way that is scientifically valid?
It's a really good question, and it's one I think most scientists struggle with. You know, if I start telling someone about global warming or climate change, individuals can't stop global warming. That is not, you know, while we can all try to live a better life and try to, you know, be carbon neutral and all that, really that's the job of countries and governments to take corrective action on large scale policies. It's very difficult. However, I think we need to, you know, educate people on issues that they can control, such as plastics pollution. Don't use single-use plastics. Don't use that disposable water bottle. Make sure things are put into the right kind of trash container so they don't end up in the oceans or in rivers and get washed into the ocean. Same thing with nutrients. I mean, humans do a lot of pollution. Don't over-fertilize your lawn. A simple step you can take. Listen to your local county regulations on, you know, keeping your septic system up to date if you have one, or having it regular pumped and inspected. There's a lot of those kind of actions that are very personal that people can do. And it's really important. If enough people get together and do it, it does make a difference. You know, asking people to stop global warming, as I said, is not probably a realistic thing to do. We have to depend that our politicians will listen to us and take the large scale corrective action. And that's what I would say is another really critical thing that individuals can do. And that's becoming educated on the issues and then becoming politically active. And I only mean you just have to vote. Vote for candidates, doesn't matter what party, that you see are working on the problem. That they support what we're doing, they support conservation efforts, they support trying to work towards healthier oceans. That's critically important to change political will. I mean, we can all do that.
So do you think that this is where we seem to be getting into trouble? Because if you're talking about overfishing and I'm in the fishing business,
yep,
right, you're urging me to fish less, or fish differently, or catch different things, or cultivate fish instead of going and catching wild fish, right? You're going to affect my business. If you're trying to suggest that maybe we shouldn't be transporting goods all over the ocean for each part of the supply chain, because that's putting pollution into the oceans and it's causing the use of fossil fuels to transport, you're affecting my business. Are we in this situation where almost anything you do is going to affect somebody? And so a good way to defend my business and the way I behaved is to undermine your scientific perspective, and basically, instead of listening to the science, basically figuring out a way to get that science discarded. And how do we change that? Because it seems to me that while governments are the solution to a lot of things, it's the collective action vehicle that we all have. I think we actually have a human issue of how we are going to interact with science. And we're going to talk in the next bit about the science that you are doing. But is there an issue here that we have to start thinking in terms of how we interact with our world in a way that makes it more sustainable so that our kids and grandkids can enjoy it as well?
Yeah, and it's a very difficult problem, but I think, you know, environmentalists, scientists, we all have to be realistic. We can say, well, you can't do this, you can't do that, that'll save the world. But it's not realistic to all of a sudden stop business. A good example is when the pandemic hit, we saw a massive change in air pollution over major cities because people weren't driving, people weren't going to work, they were staying at home. That was great for the atmosphere temporarily, but we can't realistically expect people to just stop what they're doing. So we have to provide alternatives. We have to provide better ways of doing things so it's more efficient. I mean, we have to work with people and their interests as well. So you can't just dictate that, oh, it's going to be this way. For some things you may have to because it's the only solution. For example, certain fisheries that essentially are tapped out, you may have to put quotas and limits on them.
Well, that's what they did with the Monterey fishery a very famous example of where an entire fishery collapsed after the season where they had the maximum harvest that they'd ever had. And the next year it was all gone. I mean, just gone.
Right. And that's where a scientist can actually be instructive. They can say, okay, we're putting in quotas, but we're doing this to save your job. Because if you don't do this, our prediction is the fishery will collapse. And then you're not going to have a job at all. So would you rather have some living or no living at all? And that is a good example of, okay, they kind of saw it coming. And we're now seeing this in the Alaskan crab fishery, where this is an intersection of global, warming, the ocean's warming, which is another huge issue, part of global warming, where the fishery itself, the animals can't take that slight change in temperature. They either start to cannibalize each other or move to colder waters, and they're suddenly not accessible to a fishery. That fishery basically shuts down. So, I mean, at some point, people have to realize that we're science and environmentalists, we're not against people. We're trying to protect them. I mean, we're trying to protect people's livelihoods and the oceans at the same time. I mean, but it's a difficult balancing act. It's really hard. I'm not saying
the crab fisheries are such a great example because it's just happened, right? I mean, basically, it was a slow-moving problem that some people were warning of, but you couldn't feel it until now. It basically shuts it down. Is that fishery totally shut down at this point?
I believe they stopped the harvest for this year. Yeah. So, but I do think I thought, and I'm not going to say that this is gospel, but I thought the people looking at the juvenile recruitment, they actually had a good recruiting class of larval crabs this year. So there's hope that the fishery itself will rebound. If they, like I said, you put in a quota or you stop it for a year or two and let the population regrow, it doesn't solve the underlying issue, though. And the underlying issue is the water's getting too warm for that species of crab. It needs to move to colder water. We see this on the East Coast of the United States, where entire fisheries start migrating north. American lobster,
the American lobster, right? So Maine is moving now into Canada, and you have that whole fishery that is basically in a slow decline, but a consistent decline. And there you have a border. So now you can't just migrate north. At a certain point, you get into the territorial waters of another country. And then what do you do, right?
Yeah, I mean, it's good. It could be good for Canadian fishermen. It might not be good. It's so good for the American fishermen. But that's a problem that's not going to go away easily. And there's no real regulation you can put in to fix that problem. It's just what nature's doing. On the flip side, we have the other way where organisms and, different animals that live in warmer waters down by the equator or the Caribbean are now able to come further north because it's warmer water. Right. So we can start seeing this with things like harmful algal blooms on our coast, where species of algae that wouldn't have been able to survive in our waters due to winter and cold water can suddenly persist. And we have these lingering problems that if it wasn't for the temperature of the water, we wouldn't have. So it's there's not a lot we can do about it, short of reversing the climate trend.
So talk a little bit about how you determine, as the executive director of the Harbor Branch Oceanographic Institute, at Florida Atlantic University, how do you set your research agenda on an annual basis? How do you also decide what grants you're going to go after? Because, if you're just chasing money, then you can be all over the place and the research doesn't connect and it doesn't necessarily connect to your competency. On the other hand, you are following certain areas where funding might be available. How do you create that balance and you assure that the organization is sustainable itself as it pursues sustainability in the environment?
That's a great question. And this is one of the reasons why, all institutes do strategic planning, but we constantly update our strategic plans due to where federal priorities happen to be. It's a moving target. Federal priorities change with administrations or problems that are going on. But we have 4 core areas that we work in and our faculty work in. One is marine conservation. So we study, all kind of animals from viruses to whales. So we get it pretty much covered. But also, looking at fisheries, looking at marine mammal health, looking at coral reef health, seagrass health, all those things fit with other conservation efforts. And we go where the money is and we try to develop programs where we can get funding in there. We have a very large aquaculture program here, one of the largest aquaculture facilities in the state of Florida. We have a really large project with the USDA, a reoccurring funding from the government to improve U.S. industry in aquaculture. We lag way behind the rest of the world right now. It's, we were talking about seafood and fishing. 50% of the seafood we now eat comes from aquaculture. It's not wild caught anymore, half of it. Unfortunately, of that 50% that is grown, a very small, I think it's less than 5%, is actually produced by the United States. So it's a huge trade deficit for us. It's a big problem. And we work on that and we work with the government to try to make the U.S. better at it. We also use aquaculture for restoration efforts, restoring coral reefs, restoring seagrass, restoring fish species that are being overfished or need to be restocked, just like you restock a pond.
Right, coral reefs. I was just over at Mystic Aquarium where we're doing the search for their CEO, and I was talking with a jellyfish guy who was talking about, growing jellyfish and using jellyfish not only for the exhibits for educational purposes, but also as a food source for other species that consume
Turtles.
those
Turtles like them.
turtles and other species. The thing is that if we're growing these organisms for animals, and if we are confronting an overfishing catastrophe in our oceans, why isn't the United States more on top of this industry? Because there's a real economy here that we could be a leader in.
Well, and I think part of it is straight economy. So most of the aquaculture in the world is done in Asian countries. And
Right.
Traditionally, they don't operate under the same environmental regulations. So they might be able to do things quite a bit cheaper. Labor costs can obviously be cheaper in some countries compared to the United States. So they can essentially undercut U.S. producers.
Right.
But there comes a point where, okay, we can actually compete. If we're efficient and we're good at it, we can make it profitable for U.S. industry. And that's where our research comes in, to make it profitable, to make it something that where we can compete with these other global interests that have been doing it far longer than we have, more successfully. So that's exactly what we're working on, is trying to make it better.
Here's the interesting dynamic, right? On the one hand, universities are the vehicles of business, trying to help these industries compete. On the other hand, scientists can be providing data that industries don't welcome because it requires them to change. How do you create that relationship that is respectful, productive for all sides, creates a change in behavior that is also based on economic sustainability? Because sustainability is not just about environmental sustainability. People need jobs, right? And we need work product in this country. How do you create that new balance And what kind of relationships and conversations do you enter into in order to drive forward that sort of beneficial relationship between scientists and industrial economic interests here in the United States?
Yeah, it's difficult because science really has to be careful about, taking political stances or taking, oh, we're going to support this business over that business.
Right.
I mean, science should be generic and for the purpose of just benefiting society.
And neutral, the quest for knowledge, right?
And neutral. But I will say that, I would say in the last decade, science, there's been more of a drive from governmental funding for science for it to be societally relevant. In other words, research in a vacuum doesn't do anything for anybody. It's the application of that research to benefit society that's important. So we do a lot of ocean technology development and innovation. We do that as scientists, but we give that over to industry to develop and use and make money off. Because we're not going to do it as a university, but that's where we're promoting business and trying to help businesses like agriculture technology. We do ocean health and human health research here, where we're trying to develop new drugs and new therapies for cancer using natural products from the ocean. Again, we can develop and find a promising drug and hand it over to a pharmaceutical company. So again, we're helping society, and then it gets into the business realm, and other people can be successful with it and make money. So we do a mix of both, but I would say most of our research now is applied and should have some relevance to help society. I mean, that's where we are.
I think that idea of relevance to help society, right? Knowledge is neutral. Yeah. Knowledge just is a benefit in and of itself. It's how you apply that knowledge, yep. Right? So you could take knowledge and find that you have been able to identify a substance that has an effect on the human body that, if it's used in one way, can poison it, and another way can heal it, right? So your how you actually apply it, the whole idea of scientific ethics is really about the downstream impacts of research and how that's deployed. And that really does take education, knowledge exchange, sharing of values, and engagement across different boundaries. And do you actually have engagement with community interests, business interests, governmental interests, and so on, in terms of your decision making as to what you study and how that knowledge is shared outright? Do you have boards and advisors that cross different sectors outside of the university environment?
We do. We try to stay very active with our local counties, our state government, our federal government. I go to DC and talk to senators and congresspeople about these are things we'd like to see the government support because we think they're important, and they're research that we can do. Environmentalists,
business interests, and so on. Do you?
Right. No, exactly. And we work with our particular institute works with a lot of corporate partners. For instance, we work with a lot of DoD interests. We do a lot of DoD research here because the ocean is used by the Navy and other, groups. But we work with a lot of corporations, helping them carry out their research, where they might not have expertise, but we do. We do that all the time. Very, very common. I would say, though, a lot of professors also interact directly. For instance, here's an example. I was appointed by our governor to serve on his blue-green algal task force. So this is a group of scientists who advise the state how to deal with a problem we're having right now, these toxic algae blooms in our freshwater reservoirs and sources. And they're toxic to humans, and they're dangerous to the population potentially. And it's straight volunteer effort. I don't get paid for it. And I just advise the state government on, here, this is the kind of research we can do. This is what we think will help, and just make recommendations to them. A lot of scientists do that. Many scientists volunteer their time to help out state businesses. We serve on boards. Almost everyone here will serve on some national board, and that's pretty common across all universities. So
It's so important. We've interviewed people like Ducks Unlimited. We've interviewed various conservation organizations, the Nature Conservancy, Sierra Club, and so on. Chamber of Commerce's CEOs of large businesses, always about surrounding nonprofit type organizations, issues, and leaders. And what you find is that if we talk to each other and we learn from each other's perspective, we can actually improve the outcomes that we're all pursuing in our different ways. And we can find ways to triangulate against interests that seem to be diametrically opposed, but really aren't, because we do have a shared objective. We want to make the earth livable. We want to make this a good and prosperous country for all of its citizens. And so with that common objective, we can get over those divisions.
We can, and we call it the blue economy. So the oceans and our freshwater resources are incredibly important to the economies of so many states and the nation. I mean, it's a huge issue. And yes, clean water and a good and healthy environment is part of that. I mean, if you're going to have tourism based on, the beauty of a beach or something, hey, that benefits the hotel owner, it benefits the people running restaurants, but it also benefits nature, that we actually are trying to keep it clean. And we always now think in terms of the blue economy. That's how we can get businesses interested in what we do. We can get politicians interested in it. And it's good for business. And we both want the same thing, maybe for slightly different reasons.
And good for life, good for Florida. Dr. Jim Sullivan, Executive Director of the Harbor Branch Oceanographic Institute at Florida Atlantic University. Thank you so much for sharing your perspectives, your research, the work of your colleagues there, your donors, your students, your volunteers. This has just been a terrific conversation. Thank you. Thank you for your time, and thank you for your knowledge.